So diagnosing soft foot. So what we're going to do here now, to dive right into it and not keep going on these slides here, get you some action. We're going to do the live presentation here. We're going to pull up our Rotaline Touch. And so what we have here is a simple pump motor, and we're going to simulate how to check for soft foot first, and then dive into diagnosing it as well as correcting it using a procedure here we'll show you guys. This isn't just for the Rotaline Touch. This can be used on any laser. It's not specific to the Rotaline. We do recommend a Rotaline. But we have a machine with 4 feet. You can see the 4 boxes flashing. And on the Rotaline, if you don't know what to do, very easy. If you're first time using it, one nice thing about it, if you just look at the bottom of the screen, it will actually walk you through step by step how to do this. So not too much training needed, very short learning curve. So if you read the bottom here, it says tap any value field to start soft foot measurement. So we call the boxes that are flashing with the 3 dashes, those are fields. So here we have a simulator set up. We're going to go ahead and we're going to touch. You could start on any foot you want. It doesn't matter. So we'll go ahead and we'll touch one of the fields. Once we do, it focuses on that foot. The box turns green, and it'll show you a wrench. And you're not sure which way to turn it. It shows you which way to turn it. The bottom says to loosen the bolt. We loosen the bolt. It then reads how much essentially that foot comes off the base. You then touch that field and lock in that value. So you see here that first foot essentially came up 2.5, and we are in thousandths. So 2.5 thousandths off the base. You then repeat the process on the other 3 feet. So here we go to the next foot. We touch the field, righty tighty, lefty loosey, as in the image here. We loosen it, it reads it, then it tells you tap the soft foot value field. We lock it in. The wrench comes up again. The bottom tells you to tighten a foot. This one here, 1.1 thousandths. We keep going on the 3rd foot. Again, tap the field. We loosen the bolt. It reads the value. We touch the value field, locks in the value, and retighten. And then the 4th and final foot, repeat that same procedure. So you can see how quickly this is to check for a soft foot. Okay, so again, all we did here was loosen each foot and determine where or if we have a soft foot in the machine. A quick indication where you can see is you can see that sad face. So it's telling us we do have a soft foot. And if you touch on that sad face, it tells you the tolerance for soft foot is 2 thousandths. So any value that's over 2 thousandths is considered a soft foot. So looking here, it may appear we have 3, right? We have a 2.1 that's considered a soft foot, a 5.0 that's considered a soft foot. We're good at the 1.1. 2.5 is considered a soft foot. One thing to really understand here is these are raw values from the machine, from your laser alignment system. These are not, and I'll repeat, these are not your shim values. What I mean by that is don't put 2 thousandths under that 2.1. Don't put 5 under that 5. Don't put 2.5 under that 2, under that 2.5. This is raw data. It is not your shim values. It is only an indication that soft foot is present in your motor. You must apply this next step. This next step is the procedure. Again, it can be applied in any laser alignment tool. It is not specific to the Rotaline Touch. So, to dive into the procedure to find which foot exactly is a soft foot and how much we need to add to that foot, we'll run this procedure. So the procedure says to find the highest foot, the foot showing the largest value. So we're not touching anything in the computer. We're physically going to the machine, and I'm going to loosen up the foot showing the 5 thousandths. So I've now loosened the foot showing the 5 thousandths. It then tells you to loosen the foot diagonal from it. So in this case, it is the other large soft foot value, which is the 2.5. But what I want to tell you is it doesn't matter. I don't care, okay? Using this procedure, you're always going to loosen the highest foot and the one diagonal from it. Now, what did we do here to the machine, or to the frame of the machine, I should say? We spoke about it earlier. When you have a soft foot present and that foot is tightened down, you're distorting that frame. You're putting that frame in a bond. So by loosening these 2 feet, we then relax the frame of the machine. So that plane between the 2.5 and the 5 thousandths, that plane is free, and the feet now are free to move. There's no restriction. So what we do now is we remeasure those 2 feet that are loosened. So we'll start with the highest foot again. So on your rotoline, you'll go ahead and you'll touch the 5.0. And this time, instead of loosening the bolt, it's already loose, we're going to tie that foot down to the base, and we're going to get a value. Now here you can see the value is much higher. Why is that? The reason is there's no restriction on the other side. In soft foot, one foot affects another foot. And as I mentioned, now that that plane is open and that foot is free to move, it gives me the true gap underneath that foot. So now we have our shim value, and that shim value is showing an 8.6 thousandths gap underneath that foot. I'm going to round up here 8.6. So to fix that foot, it's going to require 9 thousandths shim. Once that foot is tightened and we got that value, always remember you have to loosen that foot back up. So again, we're back where we were. The 2 feet are loose. The frame is relaxed. We're now going to measure that 2.5 the same way we did that 8.6. So we're going to touch on the 2.5. And again, the bolt is already loose. We're going to tighten it down to the base. And as you can see, even though it was showing a 2.5 before, there actually is no soft foot here. The gap is only 0.2 thousandths. So as you can see, this is why we have to perform this procedure. You cannot use those initial raw values. In soft foot, one foot affects another foot. So in fact, just like the rocking soft foot example, we're going to put shims underneath that 1 foot, that 9 thousandths, right? Just like we did a napkin or that sugar packet, right? To stop the rocking. The other foot, we don't need to put anything under. It's only showing a 0.2 thousandths gap. Now, one thing to bear in mind when we are shimming feet, you want to make sure you pick or select the correct size shim, right? So there's sizes A, B, C, D, and so forth. The correct size shim is going to be the shim that covers the entire surface area of that foot. 2, we spoke about it earlier. You want to remove those dirty, corroded, rusty shims, right? Replace them with new shims. Thirdly, we spoke about this as well. Consolidate your shims down. 5 shims or less, no more than 5. Another thing to keep in mind, if you're using thin shims, your 1 thousandths, 2 thousandths, 3 thousandths, the little thin ones, you want to make sure and sandwich those between your thicker shims. Why do we do this? Multiple reasons. More commonly, those threads on the bolts, right? If you have that shim on the top or bottom, those thin ones, you run a risk of getting caught in those threads and going into the bolt hole. So sandwich those thinner shims between your larger ones. Also, when you get to your thicker shims, those 50 thousandths, make sure you're miking your shims. If you don't have a mic in your kit, make sure to put one in there. Once you get up to 50 thousandths, it could be plus or minus 4 thousandths. It's very important to mic your shims. Once you're ready and you're inserting your shims for correction, you want to insert that shim all the way to the bolt hole through that slot and back it out just a little bit. Lastly, when you tighten down that shim, make sure you're using torque values. Each specific machine should have a torque value. If you don't have it, the manufacturer doesn't supply it. It's not given to you by your engineer. Make sure the same guy is tightening all 4 bolts, okay? So here, let's go back to the presentation. So we went ahead and we shimmed 9 thousandths underneath that 8.6 as a rotoline required. So the next step here in the soft foot process is we're going to do exactly what we did the first time. We're going to do a soft foot check. So we're going to check all 4 feet again, just like we did before. Doesn't matter which order, make sure you check all 4 feet. So we'll start here on the one we corrected, the 8.6. We'll loosen the bolt. And as you can see, that soft foot has come down to 8.6, down to 0.3. Very important. We're checking all 4 feet. Do not just correct or check the feet that you corrected for. Why do we do this? A, to make sure we did fix the soft foot we had, but B, to make sure we didn't create a new soft foot in the process. Again, we mentioned adding shims underneath the foot and how one foot affects another foot. So we're making sure we corrected it and make sure we didn't create a new one in the process. And so as you can see from the example here, that 10,000 soft foot, we had 9 thousandths, and we now have the smiley face. All right, and so lastly, benefits of soft foot. Why do we correct it? Well, as mentioned, soft foot will extend the life of the machine and its parts, right? All the components we mentioned. It is extremely, extremely important to check and correct for soft foot, and check and correct for it first before aligning your machines. So of course, it'll make your alignment faster, much smoother, but remember the whole point and why we're aligning machines to begin with, right? To extend the life of the machine and its components. So I hear it all the time, we can align it without doing a soft foot. It takes too long. We don't need to check it. You do need to check it. You do need to correct for it. You are defeating the purpose and you're doing an injustice to your machine by skipping this step. It's a very crucial step in your alignment process. Always do a soft foot and always do it first.
Thank you for watching. If you have any questions about today's session, or if there are any other topics you'd like to see covered in the future, please drop a comment below. Thank you.